See if your answers agree with me. Number 1, a Pearson of 1 is no relationship. False. What would make that true? A Pearson of 1 is a strong, perfectly strong relationship. Very nice. The perfect direct relationship. Number 2, a Pearson R 0.5 is called moderate, more likely to be called moderate than weak. True, absolutely. Number 3, same thing but negative 0.5. True, yes. When they fall right in the middle of perfection and nothing, we call them moderate relationships. Sometimes they'll say moderately strong because researchers want to say that they found something. Number 4, negative 0.97 is very weak. False. It's very what? Strong. Good. 5, R is the strength and direction of a relationship. True. Nice. 6, R is a type of correlation coefficient. True. What's the other one? Spearman. Good, Mr. Spearman. Number 7, it's extremely strong. A Pearson R will have a value greater than 1. False. Can't be greater than 1. Number 8, 0.95 is a very strong relationship. True. Number 9, the maximum value of R is 0. False. Because number 10, the possible values range from negative 1 to 1. That one is true. So the maximum values are negative 1 and 1. 11, the purpose of R is to establish measures of central tendency. False. Wow, this is a blast from Module 3, right? What are measures of central tendency? No, wait, Module, anyway, what are those measures of central tendency? Mean, median, and mode. Very nice, good. Number 12, all negative relationships are weak. False. Number 14, if the R's between two variables is very strong, that's evidence that a variable affects the other variable. False. What kind of study do we need to show cause and effect? True experimental design. We don't have it with a correlation coefficient. We can do that to see if it's cause and effect, but just this type of stories. Yes.
So I know that we skipped number 13, but in order to solve the riddle, was that one true?
Yes. That is true. If you want to solve the riddle, number 13 is true. Forget about the riddles. Any questions on this before we learn one more and very last statistic that you will learn? I know you're sad and broken-hearted. It will be the last one. The questions about the correlation coefficient.
How does number
Because the correlation coefficient does not tell us about cause and effect, we might want to get more information from that coefficient, and we can by simply, did I hide the chalk? By simply squaring R. Coefficient of determination. That's pretty easy, right? R squared. I don't need to give you the formula for that, right? Nice, just very easy, simple formula. To get the correlation of coefficient, use square R. Let's say we're looking at hours studied, GPA, and we find a relationship of that. describe that relationship. Strong, direct, very nice. Calculate the coefficient of determination. What'd you get? What'd you do? Calculate the coefficient of determination, which is r squared. So r is equal to 0.9. What's the coefficient of determination? Yes. So 0.9 squared is equal to 0.81. Get a new statistic here. So let's talk about how to interpret that statistic. The coefficient of determination is the amount of variance that can be explained by one variable on the other. One variable on the other. The amount of variance that can be explained by one variable on the other. So let's talk about what that definition means. When we use the coefficient of determination, we convert the decimal to a percentage. How do we say we convert decimals to a percentage? Yeah, multiply by 100. So 0.81 is the same as what percent? 81%. Very nice. Okay. So what we can say is 81% of the variance. And what do we mean by variance? GPAs differ, or are they exactly the same in everyone? They differ. So if you want to think about it, you can think of the word differences. 81% of the differences in GPA, as GPAs differ from person to person, and we're trying to explain why do they differ. And 81% of those differences can be explained by differences, or by the variance. And we're thinking of the word differences in our study. Can explain. We get a group of people together that have different GPAs. We can explain 81% of that difference by looking at what? Our study. We're still not saying cause and effect. We're just explaining the relationship. Okay? We're saying we can explain 81% of that relationship. Is that 100%? No. So how much unexplained variance do we have? Unexplained. $100 minus 81 is 19%. 19% unexplained variance. What other things can explain GPA besides how much you study? Intellectual abilities. Exactly. Stresses going on in your life. Motivation. A lot of things go into that. Make sense? Let me give you another example. Let's say that we're looking at teacher support and dropout rate. First of all, are those variables or constants? Variables, of course, that's going to vary from teacher to teacher. And thank goodness that's not a constant, that not all of our students are considering dropping out, right? Yay! Say we do this study then, and we have an R equals negative 0.6. So describe that relationship.
Strong numbers.
Why strong? Yes, why strong?
It's strong because it's close to -1.
Yes, it's closer to -1 than it is to what? 0. So negative 0.5 right in the middle. Below negative 0.5 is weak. Above negative 0.5 would be strong. So inverse means as teacher support increases, dropout rate decreases. Or as teacher support decreases, dropout rate increases. Calculate the coefficient of determination, please, and then convert it to a percentage. So a negative times a negative is a positive, so it's 0.36. And 0.36 times 100. How can we put that in a sentence?
36% of the variance in
Teacher support.
Yeah, it doesn't matter which one you put first, but you can think about which one makes more sense to the brain, and I would think putting dropout rate first. 36% of the variance in dropout rate can be explained by the variance in teacher support. And again, you can put it the other way, and it's fine, but that makes a better sentence. And how much unexplained variance do we have? 64%? So now we have 64% unexplained variance. So even though we had a strong relationship, what happened when we squared it? That number really shrunk. So the smaller this number gets, the more it shrinks when you square it. 0.7 is a strong relationship, right? Square that, you get 49%, and that's not even a majority. It's close to it, but 49% is not a majority. Ask the people in the last election, right? It's not. Cool. So when we square, that's why they're trying to get relationships just as strong as they can, so that they can explain at least a majority of the variance. Questions on the coefficient of determination? Well, let's try then the next set of true-false. Several absent. Is Kate here? Kate and Holly, Joey, Marcy, Natalie. She's not you go back to work, I'm sorry.
Yes.
I'm looking at, it's like, I don't remember having a Julie. Betsy and Tori Dennis. Another minute, good. See it. Go ahead.
Yeah, okay.
Let's see if we have the same answers. Pearson R 0.5, the coefficient equals 0.25. True, because they squared 0.5, right? Number 2, Pearson R is negative 0.6, the coefficient of determination is 0.36. True. Again, we had to square the R. Number 3, R is 0.75, 75% is explained. False. What did they forget to do? Square it. You have to square before you can start explaining. Number 4, R negative 0.4, 40% is explained. That again is false because they didn't square. They did not square it. It should be 16% is explained. Right? Number 3 should be, I can't do that in my head. Number 5.9, 81% of the variance is explained. True. Yay, they finally remembered to square. Number 6.8, 36% is not explained. True. How do we get that? Squared it to get 64%, right? And subtract 100 minus 64 is 36. Very nice. Number 7, R may be thought of as a proportion when multiplied by 100 yields the percent of explained variance. False. Because the Pearson R is simply strength and direction of a relationship. And you can take out the word Pearson R and replace it with coefficient of determination. Yes, they need to take out Pearson R and say the coefficient of determination may be thought of. Good. Number 8, the square of R is known as the coefficient of determination. True. Number 9, R is negative 0.36, so the coefficient of determination is negative. Well, I see that and I know that is false because if I square a negative, I always get a positive. 10, R is 0.22 or negative 0.22. About 95% of the variance is not explained. True. Good. Square 0.22 and what do you get? 0.0444, right? So if you subtract 100 minus 0.044444, that's about 95. If you round that up, that would be 95. So about 95% is not explained. Make sense? Number 11, negative 0.62, majority of the variance is explained. I'm hearing both. What do we have to do to determine how much is explained? First, what do we have to do? Square that. Will we get a number larger than 50%, larger than the majority? No, no. So since it's lower than 50%, majority is not explained, so that would be false. That would be false. And 12, making predictions, negative 0.78 is better than 0.52. True? Absolutely. It's a stronger relationship. 13, a simple correlational setting is not suitable for identifying cause and effect. True. This is not created by me. It comes from a book called Statistics with a Sense of Humor. I actually thought about changing that one, but you know what? No. I'm going to review from Module 1. You know I didn't write this because what's wrong with number 13? You don't use what in true false? Not. You just don't do that, right? It's a bad item. They haven't had this class. They're statisticians. So even though statisticians like to act like they are really smart, know a lot, they didn't know that, did they? And you know it. I would like to do the next one together before I let you go away to eat your turkey for next week. Let's talk about how these types of coefficients can apply to assessment. We're starting to look at standardized tests now. Wanting to know that those standardized tests are reliable and valid. They use correlation coefficients to do that. For example, this is a behavior rating profile. They do have an assessment called behavior rating profile. It would be given to the teacher, and the teacher would rate the behavior of the child. Sometimes that can be if the child is being considered as behavioral disorder. We want to make sure that we look at different rating scales. It's called the VRP. It's been revised, and also VRP 2nd edition. 3 different types of scales. One scale, the parents rate the child. Things like the child's verbally aggressive, the child is shy and clingy. The other one's the teachers rate the child. So the teacher might be asked things like, is the child an academic underachiever? Or the child doesn't follow class rules? And it's a Likert type scale. The teacher says strongly agree, that type of thing. And then on the other scales, children rate themselves. The children have to say, I often break rules. Or my teacher gives me work I can't do. And their friends are given it. Tell me about your friend. Other kids don't seem to like me very much. They give this scale to a group of parents and teachers and children, and they waited. How long did they wait? Let's see. Group of students, I think it says 2 weeks in there somewhere. Yes, 2 weeks. They wait 2 weeks. Then they come, I want y'all to come back. After 2 weeks, come back, and they hand them the same scale again. Did they teach anything? No, they don't want them to learn anything new. So if someone rated a high score the first time and nothing changed, when they come back in 2 weeks, it should do what again? High again. They're trying to show that their scale is reliable or consistent over time. That's one way to show reliability or consistency. Give the test, wait 2 weeks, give it again, and hopefully you get the same score if nothing has changed. They get some coefficients ranging from 0.78 to 0.91. If they got some coefficients, that means they had to have 2 or more variables. What do you suppose the first set of variables were? The scores from the first administration. And they wanted to know if the scores from the first administration were related to the scores on the second administration. So if you scored high the first time, what should you score the second time? High. If the child scored normal the first time, they should score what the second time? Normal. If the child scored low, they should score low. The child shouldn't change in just 2 weeks, right? Especially if they're behavior disordered. Child behavior, you know, rating the same child. So let's look at what they have and see if we can answer the questions. They provided the Pearson R. So in looking at those, which one is the most reliable and why? Very nice. Teacher rating scale because it's the strongest relationship. It's the furthest away from 0. Right? It's 0.91. It's the furthest away from 0. It's the strongest relationship. Very nice. Which one of the scales is the least reliable?
Student rating scales, home.
When we asked the students to rate themselves at their own house, that was the least reliable because it's the smallest number, right? It's the closest to 0. But it's still 0.78, so is it strong or weak? Strong. Still pretty impressive. We're trying to measure behaviors. All right, number 3. In your opinion then, are the scales adequately reliable and why? Yes, they're all strong relationships. They're all strong relationships. And do you think it's easier to have a reliable scale for behavior or something like math achievement? Math achievement is much easier to do. I mean, usually if you get a 98 on a math test, come back 2 weeks later, you're probably going to get close to what? A 98. I mean, you know, but if you fail the math test and don't learn anything new, you come back in 2 weeks, you're still going to do what? Fail the math test. If those were correlations that were related to math achievement, I wouldn't be as impressed. Because I would expect 0.8 and higher. But since this is a behavior rating scale, my goodness, I'm very impressed. Especially that 0.91, wow, you know, it's good. Pretty good. All right, number 4, they did one study. So, is that enough? Do you think that the world should quit doing studies on this? No. The answer to this, big clue here, the answer is always, yes, more studies are always better. More is always better because it provides more evidence that maybe your school wants to invest money. These assessments are not free. They're not cheap. But look at what they did. They only looked at 36 Indiana high school students. This is on 36 students in Indiana. That's not, yeah, I want to see some more studies. Just because it works with 36 kids in Indiana, does that mean it's going to work in Montevallo, Alabama with our students? Maybe, maybe not. I'd like to see more studies than that. Than 36 students in Indiana, right? For some bizarre reason, they admitted the decimal, so answer number 5. If they were not admitted, what would the reliability coefficient be for the parent rating scale? Parent rating scale should say R is equal to 0.84. I don't know why they left the decimals off. This is the only researchers I've ever seen do that. Usually they tell you it's 0.84, 0.91, but they did for whatever reason. Number 6, the test-retest reliability quotients are based on a 2-week interval. They waited 2 weeks before they had the people come back. Do you think this would be higher or lower if they had waited 2 months? If you think that the scores would be more or less similar to one another if they waited 2 months? Less similar, so that means these would be higher or lower? Lower. Make sense? Because you know what happens with time? Time changes things. So they usually don't wait 2 months when they're doing these retest reliability studies. They usually wait about 2 weeks because they know time does change things. And they want to be able to sell their tests, so they want to be able to say that it's got strong relationships. They don't want to say, oh, we've got some weak relationships here. Spend $500 on this test. Does that make sense? The longer the time, the weaker probably the relationships will be. Well, let's speculate then on, well, if it's stronger if you don't wait, why not just have them do it in a row? Here, take it. Thank you. Take it again. I bet it'd be stronger relationships.
That'd probably be exactly the same.
And probably, yeah, pretty quick, pretty fast. So why don't they do that? Why don't they do that so that they can say, look at how strong our relationships are? Right. Because it happens just then. And we as consumers, we're not what? We're not like, come on, you did it. No wonder they're high. I can't really have a lot of faith in your test and spend $500 if, you have them do it back to back. At least wait 2 weeks. Then I'll have some more confidence in your scale. So consumers are not going to be impressed with that, even though those would be higher. Number 8, ask about what other types of reliability, which leads to what we'll be covering the last week of class. This type of reliability is called test, retest, or stability. There's 2 other types. There's internal consistency and alternative form, which we will speak to the last couple of weeks. Internal consistency and alternative form. We'll do that in December. Thank you, and you have an online day Tuesday, so I will see you